Hello, my name is Alex Showers, and I'll be presenting on Amazon Web Services Virtual Private Cloud. In this presentation, I'll be using the VPC console in order to deploy a VPC, manage the associated infrastructure. I'll be using the EC2 console in order to deploy instances within the subnets, and then I'll be using Java executables to deploy a relay network that runs across the provisioned subnets. The pros of using the VPC is that you're able to integrate services offered by AWS into an existing private network. You can deploy a private network managed entirely by AWS using VPC. The extensive configuration of the VPC is possible through the console, but managing VPCs is complex, and this could make management difficult, and VPNs and VPCs both are susceptible to single point of failure issues, and recovery is non-trivial through VPCs. From the VPC console, you can use a launching wizard in order to create a VPC, and there are a number of topologies that you can select from. This project is using a VPC with public and private subnets. And when creating the VPC, you can specify the subnets that will be associated with the public network and with the private network. You can also choose the keys to be associated with the instances that are launched within the public network. So once a VPC has been deployed, these are the resources that have been allocated with the VPC, and they're all configurable through the VPC console. The two subnets represents the public and private subnet. The one network ACL controls traffic access to the VPC. The one internet gateway means that there is one internet access point. The two routing tables means traffic is routed based on two separate sets of rules. One elastic IP means that one address is accessible from the internet. And the one running instance means that there has already been an instance deployed within the public subnet. The next step is to use the EC2 console in order to deploy an instance into the private subnet. The first image is of using the launching EC2 instance wizard. And when you're launching the instance, you choose to launch the instance within the VPC, not within EC2. And when choosing VPC, you can use the drop-down menu in order to pick which subnet within the VPC you want to launch your instance into. I know that my private subnet has a prefix of 10010 and a mask of 24, so I know that this is my private subnet. The second image is a connectivity info with the instance after it has been launched. You can see that it is associated with the VPC. I can see the key pair that has been associated with it. I can see that there's no elastic IP associated with the VPC, with the private instance, and that the private IP address that has been associated with the instance is within the private subnet. So in order to enable SSH connectivity between the public instance and the private instance, I use the VPC console in order to allocate an elastic IP to the private instance. So in this image, I've already allocated a new address, which is 107.23.52.206, and now I'm associating that address with the private instance. The instance ID here matches the instance ID in the EC2 console, and you can verify that the private IP address is within the private subnet. The second step is to modify the routing table so that traffic from the private instance is routed to the internet gateway. The first image is from the subnet table, which is accessible through the VPC console, and the subnet table shows me which routing table is associated with my private subnet. My private subnet again is 10010 with a mask of 24. And so the routing table associated with that subnet is 4AA. And the second image is of the routing tables, which is also accessible to the VPC console. And as you can see, the second entry in the routing table 4AA is routes to IB813555C6. This is the instance ID of the public instance. We want to change this entry so that traffic outside of the VPC is sent to the internet gateway. So that's what the third image is. The instance has been changed and now the traffic outside of the VPC is routed through the Internet Gateway. So now that we have an elastic IP associated with the private instance, and the routing table has been changed so that traffic from the private instance outside of the VPC is routed to the Internet Gateway, you can generate a key pair on the public instance, and then I'm copying the public key from my local computer onto the private instance. You would add the key to the list of authorized keys and then restart SSHD. Now that you have SSH connectivity between the public instance and the private instance, you should restore network isolation to the private subnet by unassociating the elastic IP from the private instance and restoring the routing table. Now that we have SSH connectivity, I'm going to deploy executables onto each of the instances that coordinate in order to create a relay application. So the three executables that I developed was transmit socket, which opens an instance of server socket and waits for a connection on port 9943. A relay socket, which runs on the public instance. It opens another instance of server socket and waits for a connection on port 9942. Once a connection is made to the relay socket's port, the relay socket connects to the transmit socket's port. Receive socket runs on the private instance, and it connects to the relay socket's port and just returns any input received. Once the relay socket is connected to, it connects to the transmit socket. And once the sockets are all connected, the transmit socket sends an ASCII echo string through the network and then just waits for the echo string to be replied. Once the transmit socket verifies that the relay is functional, it returns to the terminal and waits for user input. I developed the code in Eclipse, and after verifying the functionality, I used the export feature in Eclipse in order to create a package jar which includes the required libraries and the required executable. I tried running my application with my local computer being the internet instance, but due to firewalls or natting, I was never able to get the public instance to connect to my local instance on port 9943. So I ended up using EC2 console in order to deploy a third instance into the internet. So it's not within my VPC. So it has an IP address of 204.236.220.210, which is not within the VPC subnet of 10.0.0.0.0 mask 16. The first step is to run the transmit socket on the internet instance, which just waits for a connection. After deploying the relay socket onto the public instance, that is started with an input argument of the IP address on which the transmit socket executable is running, which is the 204.236.220.210. Once that executable is started, it just waits for a connection to its server socket. Finally, the receive socket is run in the private instance. The private instance has an IP address of 10.0.1.175, and has, again, another input argument of the IP address where relay socket is running of 10.0.0.202 is entered. Once receive socket starts, it connects to the public instance. The public instance then connects to the internet instance. Once the connections are made, the internet instance sends just an echo string through the relay, which is sent to the public instance, which then is sent to the private instance, which just sends echo back through the relay. Once the internet instance receives echo, it returns to the console and waits for user input. This is just showing continued operation of the user just entering A, B, and C. And just like echo, the value of A is sent from the internet instance to the public instance, which dumps it, and then dumps it to the console, and then passes it on to the private instance. And the private instance just echoes the value of A, B, or C, and then sends it back to the public instance, which then returns it to the internet instance. This is showing that bidirectional communication is possible, and that any connecting instance on the internet can have access to the private subnet by being routed through the public interface. And this is valuable in VPCs so that you can use network isolation and keep your backend secure from anything on the internet by having everything being routed through a public instance. So in summary, we use a VPC console to deploy a VPC network consisting of a public and a private subnet. The EC2 console was used to launch an instance into the private subnet, and the VPC was used to expose the private instance to the internet. The internet connectivity was used to configure SSH connectivity between public and the private network. Transmit socket, relay socket, and receive socket were Java executables that were packaged into jars and then deployed on the internet public and private instance. And the executables coordinated to transmit data from the internet through the public subnet to the private subnet and back. Thank you for your time.